Welcome to another video in our math series. In this one we're going to be taking a look at some trigonometric identities that are often referred to as the compound angle formulas or the sum and difference formulas. And what these formulas do is they relate the sine and cosine of the sum and difference of two angles with the sine and cosine of the individual angles. We'll also look at the formula that relates the tangent of the sum and difference of two angles to the tangent of the individual angles. So I'll start off by telling you what those formulas are, and then we'll go ahead and see how those formulas are derived. So sine of a plus b is equal to sinAcosB plus cosAsinB. Sine of a minus b is equal to sinAcosB minus cosAsinB. Cos of a plus b is equal to cosAcosB minus sinAsinB. The cos of a minus b is equal to cosAcosB plus sinAsinB. The tangent, or tan, of a plus b is equal to tanA plus tanB divided by 1 minus tanAtanB. And the tangent of a minus b is equal to tanA minus tanB over 1 plus tanAtanB. So let's go ahead now and see how all those formulas are derived. Let's start off by considering a right angle triangle, that is a triangle with a right angle of 90 degrees in one corner. And let's consider that the length of the hypotenuse, that is the side opposite the right angle, has a value of 1 unit. That being the case, the sine of the angle A in this corner is equal to the length of the opposite side divided by the length of the hypotenuse. And if the hypotenuse has a length of 1, then the sine of A is just equal to the length of this opposite side. Likewise, the cosine or cos of A is just equal to the length of the adjacent side. Now, what we want to do is to find the values, the formulas for the sine and cosine of the sum of two angles, A and B. And to do that, I'm going to take this same triangle and I'm going to rotate it counterclockwise by an angle B. So we have an angle A, there's our original angle A there, with the sine of A equal to that side and the cos of A equal to that side. And we now have an angle B here, and we want to find the sine and cosine of the angle A plus B, which is this total angle right here. To do that, we can consider another right angle triangle with the angle A plus B in one corner, a hypotenuse length of 1, and if I draw a vertical line down here to form another right angle triangle, this time bordered in red, then we can see that we have another right angle triangle with a hypotenuse length of 1, an angle of A plus B in one corner, so that means that the length of this opposite side is the sine of A plus B, which is something we want to find. Likewise, the length of this adjacent side here is equal to the cos of A plus B. And if we do something similar with the triangle, but instead of rotating it counterclockwise, we now rotate it clockwise by an angle B. So here is our original angle A, and here is our angle B. And so this angle here, which remains above the horizontal, is the angle A minus B. Now let's do something similar to what we did over here and draw another right angle triangle with a hypotenuse length of 1 and the angle A minus B in one corner, and we'll draw another right angle triangle bordered in red with a right angle in this corner. So you can now see from this red triangle that we have this length equal to the sine of A minus B, and this length equal to the cos of A minus B. So these are the things that we want to find as far as the sine and cosine of the sum and difference of two angles. We want to find this length, sine of A plus B, this length, cos of A plus B, this length, the sine of A minus B, and this length, the cos of A minus B. So how can we go about doing that? Well, let's draw even more triangles. And what we're going to do now is we're going to draw some triangles which have these known lengths of sine A and cos A equal to the hypotenuse of two more right angle triangles. So I'm going to draw two more right angle triangles. This time I'll border them in blue. And why am I doing that? You'll see in just a moment. So I'm drawing here two more right angle triangles. And the right angle in this corner and a right angle in this corner. So we now have two more right angle triangles whose hypotenuses are the sine and cosine of our original triangle. And because that's the case, let's just draw some more angles in here. We know that this angle here is B in this corner, that's that angle there, and we know that all of the angles in a right angle add up to a total of 180 degrees. So in a right angle triangle, the two other angles add up to 90 degrees. So if this angle here is B, then this angle here must be 90 minus B. And likewise, because this from here, from that point there, all the way around is 180 degrees, and that is 90 degrees, then this angle here must be 180 minus 90 minus 90 minus B, which is actually equal to B. Now, because we know that angle is B there, and we know that that length there is sine of A, we know that this length is this length divided by this length is equal to the sine of B. In other words, this length is equal to this length multiplied by the sine of B. So that length there is going to be sine A multiplied by sine B. So that when we divide that by that, we get sine B. Similarly, this length from here to here is equal to the hypotenuse length multiplied by the cosine of B. So this length is sine A cos B. So that when we divide that length, sine A cos B, by that length, sine A, we get cos B. Because that side there is the adjacent side of angle B. We can do something similar with this triangle here, and we can say that the length of this side is equal to the hypotenuse multiplied by sine of B. So this is sine B cos A, or we can write it as let's write it as cosAsinB. And this length here is equal to the cos of B multiplied by cos A. So this is cos A, this total length here is cos A cos B. So that when we divide this by this, we get cos B. So how does all this help us? Well, we can see that the length that we're trying to find, sine A plus B, that total height there, is equal to this bit plus this bit. So in other words, the sine of A plus B, which we want to find, that length, is equal to cos A sine B plus sine A cos B. In fact, you'll usually see it written as the sine A cos B term first. Conventionally, we'll see sine of A plus B equals sine A cos B plus cos A sine B. So let's write it that way because you usually see it written that way. Likewise, we want to find this length here, and you should be able to see that that length there is equal to this length minus this length, which is equal to that bit. So the cos of A plus B is equal to this length, cos of A multiplied by cos of B, minus that length, which is equal to that length, so minus sine A sine B. So those are the two formulas which give us the sine and cos of the sum of two angles in terms of the sine and cos of the individual angles. Let's do something similar now to work out the sine and cos of the difference of two angles. So again, I'm going to draw two more right angle triangles whose hypotenuses are equal to the known sides of our original triangle. So I'm going to draw a triangle here, a blue triangle, with a right angle in this corner, and I'm going to draw another right angle triangle with a right angle in this corner. Let's just border it in blue so that we can see that our blue triangles are the ones that we're using to find the lengths written in red. Now this angle here this angle here is B, so this angle here is 90 minus B because that's a right angle. So that's 90 minus B in that corner, and because that angle plus that angle will add up to 90, so this must also be B. And this one here must be 90 minus B, and this one here must be B again. So let's look at what we did before, and let's find the length of the non-hypotenuse sides of these blue triangles by knowing the length of the hypotenuse. So that's cos A, that length there. So this length divided by this length must be the cos of B. So this here is going to be cos A cos B, so that when we divide this by this we get cos B. This length down this side is going to be cos A sine B, so that when we divide that by that we get sine B. This side here, because B is over there, is going to be sine A, the hypotenuse length, times sine B. and this total length down here is going to be sine A multiplied by cos B. So again, you should be able to see now that the length that we want, the sine A minus B, is equal to this length minus this length. So that's sine A cos B minus that length, which is cos A sin B. And likewise, the cos of A minus B, which is this length, is equal to that bit plus that bit. So cos of A minus B is equal to that bit cos A cos B plus that bit, which is sin A sin B. Now you can see that the formulas that we have for the sine of the sum of two angles and the sine of the difference of two angles are just the same, except we reverse the sign. So we can summarise them by saying that sine of A plus or minus B is equal to sine A cos B plus or minus cos A sin B. And likewise, the formulas that we have for the cos of the sum and the cos of the difference of two angles again are the same, except we reverse the sign. So we can summarise those by saying that the cos of A plus or minus B is equal to cos A cos B is always the first term, and I'm going to put minus or plus the other way up to indicate that when this is a plus, as here, this is a minus, and when this is a minus, as here, this is a plus. So cos of A plus or minus B is equal to cos A cos B minus or plus sin A sin B. So these are the sum and difference formulas, or the compound angle formulas, for sine of the sum and difference of two angles and the cos of the sum and difference of two angles. Okay, what about the tangent then, or the tan of the sum and difference of two angles? Well, we know that the tangent of an angle is equal to the sine divided by the cosine. So we know that the tangent of A plus B will be equal to the sine of A plus B divided by the cos of A plus B. And if we use the formulas that we derived for the sine and cosine of the sum of two angles, we know that that equals sine of A plus B equals sine A cos B plus cos A sin B, that's the formula for the sine of A plus B, divided by, we now want the formula for cos A plus B, which is cos A cos B minus sin A sin B. And if we now divide top and bottom of this equation by cosAcosB, we get sinAcosB divided by cosAcosB, which becomes tanA multiplied by 1. So you can see sinAcosB divided by cosAcosB becomes tanA multiplied by 1, plus, let's divide this term by cosAcosB, so that becomes tanB. And now let's take the terms on the bottom and divide each of them by cosAcosB. So cosAcosB divided by cosA plus cosB, cosAcosB divided by cosAcosB becomes 1 minus sinAsinB divided by cosAcosB is tanA tanB. Similarly, the tan of A minus B is equal to the sine of A minus B divided by the cos of A minus B, which equals, using the formulas that we had before, the formula for sine of A minus B is sine A cos B minus cos A sin B, and the formula for cos of A minus B is cos A cos B plus sin A sin B. And if we do the same thing that we did before and divide every term by cosAcosB, we get sinAcosB divided by cosAcosB, which is tanA, then minus cosAsinB divided by cosAcosB, which is tanB. And now the terms on the bottom, cosAcosB divided by cosAcosB is 1 plus sinAsinB divided by cosAcosB, which is tanA tanB. And again, you can see that the formulas for the sum and difference are the same, except that we reverse the sign. So we can summarize them together and just say that the tan of A plus or minus B is equal to tan A plus or minus tan B divided by 1 minus or plus tan A tan B. Again, using this minus or plus sign to indicate that when this is plus and this is minus, and when this is minus and this is plus. Finally, let's just take a look at special cases of these compound angle formulas called the double angle formulas, and these are just when the two angles are the same. So if we want to look at the sine of 2A, that would be equal to, because we know that sine of A plus B is sine A cos B plus cos A sin B, so the sine of 2A would be sine A cos A plus cos A sin A, which is just equal to 2 times sine A cos A. The cos of 2A, cos of A plus B, would be cos A cos B minus sine A sin B, so cos of 2A would be cos A minus sine A sin A. In other words, cos squared A minus sine squared of A. Now, we have a formula which we'll look at in another video, which says that the sine squared of an angle plus the cos squared of an angle equals 1. So we can rearrange that formula to give us sine squared A equals 1 minus cos squared A, or cos squared A equals 1 minus sine squared of A. So if we substitute this formula for sine, we could say that instead of writing cos of 2A as cos squared A minus sine squared A, let's first of all replace the sine squared A by, no, let's first of all replace the cos squared A by 1 minus sine squared A. So we get that's equal to 1 minus sine squared A minus sine squared A, which is 1 minus 2 sine squared A. So all I've done there is just substitute for cos squared A, 1 minus sine squared A. Now let's instead substitute sine squared A as 1 minus cos squared A. So we get cos squared A minus 1 minus cos squared A, which is plus cos squared A. So we get effectively equals 2 cos squared A minus 1. So the double angle formula for cos of 2A can be conveniently written either as that, or as that, or as that. What about the tan of 2A? Well, we know that the tan of A plus B is tanA plus tanB over 1 minus tanA tanB. So the tan of 2A would be tanA plus tanA over 1 minus tanA tanA. In other words, 2 tanA divided by 1 minus tan squared A. So that's the double angle formula for tan. Any of these are the double angle formula for cos, and this is the double angle formula for sine. Okay, that's about it for this video. I hope you found it useful, interesting, or even enjoyable. If you did, please hit the like button and consider subscribing to the channel. And I look forward to seeing you again in the next video. Thanks for watching.